Hello everybody. I wanted to shoot a video on access lists, considering I know that they can be a royal pain sometimes. Ooh, pretty. Um, but what I really wanted to cover, well, is access lists and kind of how they work. Now, access lists can do a lot, and depending on how they're configured, how they're applied, and how you want them to be used will determine how they operate. What do I mean by that? Well, if access lists they can cover, let's see, VLANs, NAT, permitting and denying a single host or an entire subnet or subnet range or an entire Class B range or, you know, however many hosts you want to permit or deny. Um, it's basically like putting a security guard at an interface, whether you want the interface to look at traffic coming in the interface or leaving the interface, and how you want it to look at the traffic. And you tell it what to look for during the configuration process. Now, access lists, like I said, can be used to do a lot of things. Typically, you're going to see them, they're not going to be really complex, but they can get kind of tricky. But so what I'm going to do is I'm going to kind of give an overview as to how they kind of work, and well, not how they kind of work, how they do work, and you'll see access lists a couple times in the CCNA. You'll see it for being able to do traffic control, which basically is a good way to put it. Traffic control is a matter of you don't want specific IP addresses getting from one section of the network to another. So, for instance, if you don't want a standard access list in this particular example, you could say you don't want a particular IP address to get through. And what you would do is you would configure, you go into global config and you say access list 1, and you want to, if you want to, I said deny something, but we're going to go with what we have right here, which is permit 192.168.10.0, 0.0.0.255. I'm going to point this out of the gate, right here. Why is that important? Well, simple. If you have, that's better. If you don't tell it what to look for, it's not going to know what to stop. What does that mean? Well, real simple. This is called a wildcard mask. Okay, wildcard mask is the exact opposite of a subnet mask. So everybody knows a subnet mask is 255.255.0.0.0/8 if we're talking about a Class A range, right? Class A. Well, in this case, if you have a wildcard mask, it does the exact opposite. And you're like, well, what do you mean? Well, real simple. The zeros mean I don't care. Or I'm sorry, look at this. Zeros mean look at this. I apologize. Zeros mean don't look at this. This doesn't, or I'm sorry, it means look at this. The number means I don't care. Go ahead and let that through. That's not what I'm watching for. So you can look at it as the bits turned off means they have to take a look at that and say, okay, do you start with 192.168.10? Well, yes, I do. Okay. Do you? Then you're permitted because it's encompassing the entire range with the 255. If you have traffic that comes in and it's say 11, okay, 192.168.11.0, are you 11? It's going to say yep, and well, it's going to get permitted. What ACLs do is when you're configuring the iOS by default, if you don't specify a sequence number, which typically you won't, it'll give you the first one 10, the second one 20, the third one 30, the fourth one 40, so on and so forth. Why is that necessary? Well, if you don't specify, or they're looked at in order of how they're configured. So you could have a permit, a permit, a permit, a deny, a permit, a permit. Now you could have several things like deny, permit whatever, permit whatever, deny something specific maybe. You don't want inbound traffic seeing maybe a database server, then you would want to make sure that you deny inbound traffic from getting to that particular IP address. And you could do that with the host command. And then you have permit and permit. Now, the way I have this written right here, it covers pretty much everything you need to worry about. And I'm referring to the 5.5 lab in the WAN side of the section. This is CCNA 4. Everybody here is in the beginning of CCNA 3. Well, I'm already done with CCNA 3. I fixed that, or finished that. Actually today, I finished the last wireless lab. And so I moved on, and I figured this would be a good opportunity for me to discuss ACLs, considering they're not an easy topic to understand. I mean, it took me a while to get them as well. So I understand if people don't get them right out of the gate. This is more of the conceptual stuff. This explains how they work, and then I'll shoot a video on actually configuring them in one of the labs. And actually, I have it pulled up on my other monitor, which is right. I have it right here is the basic ACLs list. Then you deny certain traffic, and you permit other traffic and stuff like that. And I'll configure that stuff some other time. But the point of doing this is what ends up happening at the bottom of an access list. Let's cover that first. Is this: if you don't tell it to specifically permit or deny something, so like right here, 1 second while I get rid of all that so I don't have to. If you don't specifically say permit or deny something, it's going to deny everything if it doesn't specify otherwise. So you might have an access list 10, 20, and 30, which I've seen access lists get to say 30, 40 entries, and depending on how big your network is will determine how big your access list is, and what type of business you're in, that type of stuff. So when you get to the 10, 20, 30, so this might be a deny something specific, and this might be permit and permit. Well, this might be permit everything else that the deny statement doesn't cover, and then this permit statement had better say permit everything else, or it might be something specific like permit a particular IP address or what have you, and then you might have permit all. If your last statement in your access list isn't an explicit permit everything or deny everything, well, it doesn't actually have to be a permit to deny anything, because at the very end, down here, you can't see it when you configure it, and you can't see it when you apply it. But if you have any other traffic coming or going, coming in or going out, depending on how you have it applied, if you don't specifically say one way or the other, it's going to get denied. So if you don't want all your traffic getting denied, you would better put in permit all, or permit any in this case, if you're a standard access list. If you're an extended access list, you're going to want to put permit IP any, like that. But that's actually the easiest way to do it. Now, let me bring this guy over here just to give you an idea. And typically I don't like to do this, but I'm going to do it anyway. Now, as you can see, I won't be able to draw on this because I took a picture of something here, so that's why I'm able to draw on it and paint. But what I wanted to show you was this. If you have traffic coming inbound, let's say you're routing OSPF. Okay, you've got OSPF running, and the reason I picked OSPF is because it requires you to specify Wildcard Masks, which is this guy right here. What this guy does is, once you've configured the access list, if you have two permit statements, you permit, say, the 10 network, which is what I actually had it there originally, and you had a deny traffic inbound, or deny 192.168.10.0 or some other IP address. Let's say go with the 11 network because it's right here. If you deny the 11 network inbound on R1, which would be going this, which would be going this direction, it's not going to let it go through. Which technically isn't a bad thing depending on your situation. Now, what will end up happening? This is more prevalent on serial interfaces, but if you have a deny, let's say for instance you have, okay, well, let's do it to router 2 because it makes it be a little easier to encompass the criteria. If you have, actually, let me draw it out this way. You have a router and a router, and you have two connections outbound. If this is R2, or just put 2, this is 1 because it's skinny one, this is 3. If you put an access list inbound, meaning anything coming this direction on it, if you configure it to where it permits, or I'm sorry, we'll just go deny IP whatever, and then you put a permit just, and I mean just, the IP range that is configured on this side over here, what will end up happening is any dynamic routing protocol that you have routing to this interface, because this is going to be a different subnet address or subnet than this guy. So this guy might be the 10 network, this guy might be the 3 network, depending on your routing, your addressing scheme. If you don't do a permit any, what will end up happening is the neighbor relationship between router 2 and router 1 will fail because you're not permitting all other traffic inbound, because it needs to send traffic from this router to this router so that it can speak to each other's to each router's routing process in order for routes to be exchanged, and in order for your 10 network to route off of router 1 and get to router 2. And then if router 2 has got a connection to the ISP, which is out here, ISP. That's how access lists work. So you have to be really careful when you're configuring them, because if you don't do it correctly, you can hose yourself up. So that pretty much covers standard access lists. Let me cover extended, which is a little more difficult to understand. See what happens when you erase stuff? Okay, extended access lists are more difficult to understand, as there's more to them. But I'll try to make it, I'll try not to be too complex. So what this says is, it says deny 192.168.20.0.0.0.255 out, or I'm sorry, to host 8.8.8.8.8. If anybody has ever pinged a DNS server out on the internet, 8.8.8.8 is a Google DNS server. So it's actually one of my favorite IP addresses to ping, because it's a DNS server. I don't even know where. I think it's a university. But what this does is it says access list 100, because you have to specify the number going based on this. Oh, good point. Thanks for smacking me in the back of the head. Access lists are numbered. Standard is 1 through 99. Extended is 100 through 199. Now, if you're on the Cisco iOS and you type in standard, or if you type in access list and question mark, it will give you a whole plethora of options, because then you'll get standard, and you'll get standard extended, which means you'll be able to go 1 through 99, and then say there's an additional range of, I think it's 1,000 through 1,099. I don't remember off the top of my head. But if you don't type this in, it's not going to know what you mean. I mean, you don't have to. I don't know. I've never tried that. I'll have to give that a shot and see what happens. But anywho, as I was saying, the extended access list is where you're going to get into NAT, or network address translation, for the most part, because then you're going to be saying anything from this anything coming in on this IP address is is denied to this guy. Well, there's more to it than that, but the basic idea is this: if you, I didn't actually apply it. Shame on me, I didn't apply it. So the idea is, assuming that you're going to be going outbound. Okay, assuming that this is the outbound, you got the the World Wide Web out here, dub, and you have over here you've got the 20.0 network /24. Okay, assuming this is your configuration, if you put a deny this IP address in there, and you got this over here, and this is the 10 network. If you put a deny in here, out to here, and this is this IP address out here, then what will end up happening is if they try to ping, or this is the destination IP address to a IP address internally, this is the source, this is the destination, it will be denied. It won't go through. It's plain and simple. Now, you can get more complex than that. You can actually, you can go, how does it go now? You can go, I'm actually looking at some of my notes from when I was studying this stuff. You can get very, very granular, because extended access lists not only allow you to go based on source and well, it's actually source and destination IP address, where access list is only source, or I'm sorry, destination. No, I'm wrong. It's source. It's source, because with standard access lists, you want to apply them as close to the destination as possible. So you want to lost my train of thought. If you're gonna assign a standard access list to any place, you're gonna want to put it so if this is your connection, and let's say you got a point-to-point connection between two routers. If this is the 10 network and this is the 20 network, and you don't want the 10 network being able to talk to the 20 network, you would put your access list inbound on this interface right here, and you would, when you apply, you would apply it like this, and you would put it right here. So you put it right here, and then any traffic coming from this way here we get stopped right there, and the packets would get dropped. It would say, sorry, you matched this right here, you're not coming in. Simple as that. Where this guy right here, you can get more granular. You can say, like my demonstration a second ago, you can configure it to where it'll deny to a specific IP address, like a web server or whatever else. Now, one thing you can do, you notice how it says IP? There are, let me think here. There's, you can deny based on IP, TCP, UDP, and that's all I can think of. IP, TCP, UDP. That's all I can think of. Yeah, because that's what covers IPs, TCP and UDP. Because you can block based on the port, stuff like that. So you can go in there and be like, you can get as granular. I think it's, actually, let me grab this right here and type in here. Because you can go permit TCP 192.168.100.1 0.0.0.0 and you can go host, let's say 10.2.3.4, and you can go EQ, which is equal to say 80. So that basically that says, all typed out, is you're permitting the transmission control protocol, or TCP traffic, on from the network 192.168.0.1. Well, actually, I should say delete that and go 0. You're permitting on the entire 100 dot whatever network from host, his source and destination, or to host 10.2.3.4 equal to 80, or you can do dub or whatever. Or if you want to deny, say for instance, permit only 443, which means secure, and then you would put in deny TCP 192.168.100.0.0.0.255 host 10.2.3.4 EQ 80, meaning you are permitting only traffic from 10.2.3.4 on network 100.0, the 100 network, via secure HTTP. That's what that's saying. And then you're going to deny 192.168.10.100.0, that entire network, from host 10.2.3.4 equal to 80. So that's how you can get granular, and you keep going and going and going until, you know, it gets to the bottom. That's basically access. There's more to it than that, but that's just ACLs. Now, I will shoot another video for NAT, but I didn't want to get too long-winded and confuse anybody. But that's how you can set it up. And then down at the very bottom here, you can type in, if you don't permit it all, if you don't permit IP any from the source to the destination, any, nay, it'll deny any other traffic. Okay, so that's one thing you have to remember. So if you don't specify, because this will be like 10, this will be 20, and then they go in order. So this will be the first one it puts in, this will be the second one it puts in. So, because it go in order check. So if you might have, this will be this is technically 30. So any other traffic, so if you had the 10.7.1.1/26, any other network that comes through beyond this 30 will be permitted, no questions asked. Now, if you get the 192.168 100.66 network, let's say for instance, and it's going out port 80, it'll be denied. Simple as that. So you've got to be careful when you're configuring ACLs so that you don't configure them incorrectly, stuff like that. But I think they have videos inside of the when you're going to submit the assignments. So if I was you, check out INE.com, go to YouTube, and check out, it is, if you want some more, if you want a CCIE to tell you how this stuff works, which is usually how I do it when I go to review for a test, INE.com. You can do INE.com and do their register for free, or you can go to www.youtube.com and then search for INE training, and then once you're there, you want to search for CCNA route, and what it'll do is it'll find that for you. So it'll find the route slash switch bootcamp, because they actually post all 36 videos on their YouTube site, which is basically the same thing I'm doing, except for they do it on a they have their own training company and stuff like that. So they actually you can buy the bootcamp for $100 off their website and download it. I think I forget how big the file is. It's pretty huge. And that's what I would do if you want to get some more advanced training. And he goes in depth and he shows you how they do it. And I'm not showing you the NAT version of it because the fact that NAT can be complex, and if because there's different types of NAT and stuff like that. But basically, NAT in its most basic concept is you're taking one address and you're translating it to another. So Like if you have a public IP address of whatever.com, so let's say you have 8.8.8.8. Let's say this is your public IP address, and this is your private IP address that you're using for your local interior network. You would configure an access list to, and you would use the overload command, which means you'd be able to use more than one host, because by default, a NAT translation is one IP address to another. That's what they call static NAT. And there's another one called dynamic NAT, which is where you take, or there's actually one called PAT, which is port address, and you take the same concept as this, but then you overload it, meaning you can have, it goes into port address translation, but that's a whole other thing. I'm not even gonna, I actually went too far. So, but that's basically ACLs in a nutshell. So, if you have any questions, give me a shout. My Gmail account is right there, same, the rrecker82. Shoot me that. If you're a Gateway student, go ahead and let Rebecca know that you have a question, or you can ask her, or shoot me an email at rrecker82@yahoo. However you want to get a hold of me. But that's basically it. I mean, I could go into a lot more detail, but at the CCNA level, that's all you really need to worry about. So, I hope this has been informative for you, and I'd like to thank you for viewing.